Alright, today we're going to talk about differentiating between relations and functions. We've got a few definitions here, 4 of them, so hang in there with me. Our first definition is the domain. Alright, so our first definition is the domain. And the domain is the set of possible values for the independent variable, the input value, of a set of ordered pairs. So the domain is the set of possible values for the independent variable of a set of ordered pairs. The next one is the range. The range is the set of values for the dependent variable of a set of ordered pairs. So the only difference between the domain and the range, the domain is the independent, the range is the dependent values. Then we have the relation. The relation is a set of ordered pairs where each number in the domain is matched to one or more numbers in the range. Alright, so you have a relation if your domain each matched to one or more numbers in the range. No domain number is left alone. Lastly, we have a function. Is a mathematical relationship pairing each value in the domain with exactly one value in the range. So each input has exactly one output. Here, give the domain and the range. I'm going to list them on the side here. So we're going to go domain right here and range over here. Now you can see I have a 3 as my domain. I have a 5 in my domain. My x's are my inputs. 3, already listed it. 7 and 9. In my output, trying to go from smallest to largest, I have a 1, I have a 3, I have a 4, I have a 7, and I have a 9. So there's my domains and my range. Here I'm just going to show you that how we map this out. So 3 goes to 7. And 3 goes to 1. 5 goes to 3. 7 goes to 8, which that 9 should be an 8. 7 goes to 8, and 9 goes to 4. So that's how we mapped it out. My domain is this right here, and my range is that right there. So we got to determine whether the following is a function. Well, again, let's start with the domain and the range. Domain, range. Try to go from least to greatest. So 0. I'm checking my other x values. I have a 2. I have a 3. I have a 7. And I have a 9. My range is, I've got a 3. I've got a 1, 2, 3. 1, 2, 3, and a 7. Alright, so there's my domain and my range. Let's map it, and that will tell me if I have a function or not. So 0 goes to 7. 7 goes to 3. 3 goes to 7. 9 goes to 2. And 2 goes to 1. You can see that each number in the domain goes to exactly one value in the range. That means it's a function. Alright, that means it's a function. If they went to 2 values in the range, then it would not be a function. So, yes. Determine whether y equals 3x plus 1 is a function. What we can do is we can pick some values for x. Alright, something like 0, 1, -1, 2, 3. We gotta see, do we think we can get a same number for y? So, if x is 0, that means 3 times 0 plus 1. That would be 0 plus 1, which is 1. Here, if I had 1, 3, 1 plus 1 is equal to 3 times 1 plus 1, which is equal to 4. 3 times -1 plus 1, -3 plus 1, that's -2. 3 times 2 plus 1 is equal to 5 plus 1, which is 6. And 3 times 3 plus 1 is equal to 9 plus 1, which is equal to 10. You can see I'm not getting anything similar. All right, I'm only getting one output for each input. So you can see here that it is a function. Yes, as well. Last thing I want to talk about for functions is called the vertical line test. All right, the vertical line test. What I can do is I can draw a vertical line on the graph. If it only crosses one point in the graph, then it's a function. So you can see I draw a line, it only passes there, it does not pass anywhere else. I can do that anywhere on the graph, and it only crosses at one point. Alright, so yes, this is a function. Here, if I draw a vertical line right here, you can see that it crosses at 2 points. If I draw a vertical line right on the y-axis, it crosses at 2 points. If it crosses at 2 points at any spot, it is not a function. So that's the vertical line test. Let me know if you guys have questions. I'll talk to you later.